We've already talked about circles. We had a whole entire chapter on circles, but what did we talk about? We didn't talk about the area of a circle. We talked about the what? The circumference, right. Circumference of a circle. And what was the equation or the formula for circumference?
2 pi r.
2 pi r. Or, Ben's right too, you could say pi d. All right, but most of the time, the most common way is to say 2 pi r.
Do you have any of those little circle thingy-majiggers?
Yeah, the
They're up there on the table.
Rachel, we
Somewhere up there. All right. So anyway, watch. So we learned the circumference of the circle, which means what? If we started here and we went all the way around the circle, if we went all the way around the circle, okay, that's the distance around that circle. So we knew how to do that already. It's 2 pi r. What we're doing now, though, is we're going to find the area of the circle. And you guys you probably learned this back in 4th or 5th grade, area of a circle. Do you remember what it is? Pi r squared. So that is our area of our circle. Okay, obviously we have a radius. Oops, we have a radius. Just take it to right there. Okay, that's the radius of the circle. Now listen to this. I found this cool website right here. See how cool that is. Let's see, what do I want to... Can I scooch this over?
No, that's too many words.
Anyway, is that... I'm trying to... I guess it's in there, isn't it? It just kind of... Watch this. I was going to go through and kind of show you... This is a description of... I know some of it's cut off if you ever watch this on YouTube because it goes off the page. I don't know. Can I make it smaller? No, it just makes that smaller. Well, anyway, you get the idea. It shows you how they came up with the area of a circle. In fact, they said that Archimedes, do you know Archimedes?
No. Is he a guy?
Some dead guy.
Archimedes, some dead guy. Yeah, you're right. You nailed it. From 287 to 212 BC. All right, from 287 to 212 BC. So 200 years before Christ, he came up with this, the area of a circle. So watch this. This is kind of a cool little device.
It's crazy how people will just like figure that out like.
Yeah, I mean, it's not like, I mean, yeah. Well, anyway, let's take a look. Watch this. If I put a square inside, this is a regular quadrilateral, okay, which would be a square. If I put it inside of a circle, that square is not the whole circle, is it? It's not the whole entire area of the circle. You got all this gap of white right there. It's an approximation, but not too much. Now, if I put more sides to this, watch what happens. If I put 5 sides, those white gaps get a little bit smaller, don't they? So the area of this pentagon, right, with a radius of whatever it is from here to here. See, the circle didn't change. It's just my shape changed inside there. So the pentagon is a little more accurate than what the square would be, right? What would be a little more accurate than a pentagon? A hexagon, 6 sides. Now look, see how the white sides are closing in a little bit? So that's getting a lot closer to the area of a circle. And if I keep going more and more and more and more, watch, keep on going. Look, it's getting really, really close to the area of a circle, isn't it? And we learn how to find, no, actually we're going to do that in this chapter. We're going to learn how to find the area of these different figures, like a 6-sided figure and all that kind of stuff, okay? It goes up to 35 or 30 right there. And you can't even see the difference between it, okay? But that's kind of shows you, see, right in there. I mean, just because the accuracy of this little program that they put on here, but it's kind of neat. It gets really, really close, doesn't it? All right? Now, with that said, that's kind of, what they do in here is they make a, see, this is a, how many sides is this? I don't even know how many sides this is. We could count it up, but I'm not going to. But watch. You make all these triangles in here, okay? They come up with this formula where you get more and more and more triangles. So these triangles get skinnier, 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 and that height actually becomes the radius of the circle, right? The more and more and more triangles you put in there, this height actually becomes really, really close to the radius of the circle. It goes through some other things. I don't know if I can explain it exactly. If I take the base, multiply by how many triangles I have in here, it gives me the perimeter. The perimeter, okay, has a lot to do with the perimeter of a circle. Look at this. That's the perimeter of a circle, isn't it? 2 pi r. And so look, 1/2 the radius times 2 pi r, it gives you pi r squared. You see that? Half of the 2 cancels out. R times r is r squared, pi r squared. That's not the greatest explanation in the world of that, but it gives you an idea where pi r squared came from. Does that make sense? Okay, so that's where it came from. I just thought it's kind of interesting to see how they came up with that thing in the first place. All right, and that's how they did. We actually talked about where pi came up, where we came up with pi. Remember we did that measurement? We took that circle and we measured it, and we took the circumference and we divided it by the diameter, and we got pretty close to 3.14. Did you? Well, that's good, because a lot of teachers don't listen. Shh. A lot of teachers don't explain where pi comes from, and it's a very easy thing to do. Just take any circle, wrap a string around it, find the measurement of the circumference, divide it by the diameter, and you've got what pi is. Okay, it's not super accurate. We did it in here, didn't we?
Yeah, I did.
That's what I thought. Okay, yeah, we got pretty close. Not exact, but you know, our measurements are off a little bit. But as for the stuff that we use to measure it, it was pretty close. Okay, I was pretty happy with it. They have programs and all kinds of things that do that kind of stuff. All right, so anyway, there you go. So that's the area of a circle. It's actually very, very simple to do. So watch this. If I gave you the area, or the radius was 3, and I asked you to find the area of the circle. Now remember what we're trying to do when we find the area. We're trying to find out how many squares, right? Perfect squares can fill up this circle right here. Would you agree with that? All right, so that's what we're trying to do. Now, since you have pi in there, is pi an exact number? No. So really, our area of a circle, is it ever going to come out to a nice, perfect, exact number? It's not, because you're multiplying a number by an irrational number, which never ends, right? It never stops. So our answers, they may every once in a while round to 0.0, but that doesn't mean it comes out exactly, right? They're all going to come out to, to numbers that have decimals, basically, all right, for this. Because you can't fit perfect squares in here, because you got these curved edges, right? Those curved edges aren't going to fit perfect squares inside of there. So anyway, there you go. So let's do this real quick. To work these problems, it's easy. It's just understanding where it comes from, I think, is probably more important than actually working the problem. So it's pi what? R, which is 3 squared. So this is what? 9 pi. Now look, in my old book, from my other school that I used to teach out of, they were fine with you writing 9 pi. All right, they actually encourage you to write your answer like this. But in this book, I don't think they usually do that. So what would you do? Put that into your calculator. So 9 what? Pi. On this calculator, you can just hit 9 and then pi. You don't have to hit times. If you use that TI-30, that little one, you hit 9 and then times the pi button, and you hit equals, and you get 28 point. Let's go 1 decimal. So it's 28 point what? 3. So 28.3. So it's not exactly 28.3, is it? It's approximately. Why? Because you got that pi right there. Okay, pi is not an exact number. All right, so it's 28.3. So the big question is, do we use the pi on the calculator, or do we use just 3.14? I would use the pi on the calculator. All right, so use the pi button on your calculator, and then we'll all be consistent with the same answers with this. Everybody good with that? All right, pretty simple. Like what? On a test or quiz, I would let you do it like that, but if you're doing a homework problem, when I read off the problems, or if you look in the back to the odd problems, you'll see it written as a decimal, okay? I'm okay. I don't mind you keeping your answer like this. Like if I do an answer key for a quiz or a test, I'll probably include that as my answer, plus I'll probably put the decimal next to it. So it's fine with me if you just want to keep it 9 pi. I don't have a problem with that, all right? But if you want to be consistent with the book, I'd put it into a calculator and get that decimal answer. They could also do this. Sometimes they could give you the area. I'm just making something up off the top of my head. Actually, we already used a 20 right there. Let's use like 37.8. Okay, so let's say that I just made that up. I have no idea where that came from. Let's say the area is 37.8, and we want to find the radius. And this is the area of a circle. So this is a circle. And there you go. You just divide it by pi, and that's it.
You have to get rid of the square, so you
That's
take
right.
the square root.
You got to take the square root as well, don't you? Because look, let's put the number in here. 37.8 equals pi r squared. So you don't just divide it by pi. What else do you have to do? You got to get rid of that squared. So how do you get rid of the squared? Take the square root, put that in your calculator, and you're good to go. Now don't leave your answer like that, though. Okay, that's too ugly. So we'll just put that in there. So it's 37.8 divided by pi right there. hit equals, and then take the square root of that answer, and then that gives you 3.5 approximately. So R is approximately 3.5. If they ask you for the diameter, what do? Plug it in or just do what? Yeah, just multiply by 2 and you get 7. Does that mean the diameter is exactly 7? No, because this was an approximation. Remember, that was an approximation. But as far as just rounding, that's fine. We'll just say 7. Make sense? Easy, easy, easy. Now, back when we did the circles and the circumference of the circles, we also found the length of an arc of the circle. Do you remember doing that? We said find, I'll tell you what, let's put one in here. Let's say we have a radius here and a radius about right there. And let's say that's about, let's say it's about 92 degrees. All right, we'll make a weird number. And this is A and this is B. And the radius, I don't know, give me a good little radius. 6 is good. All right, so let's say that we have this is what's given in our circle. Now, before, in the other chapter, what did we find? We found the length of the arc, of arc AB. How did we find the length of arc AB?
It was it'd be
Right.
X over.
Well, it's 92. We know the angle, so it's 92 over 360. Now, because it's a fraction, it's a percentage of our circle, right? 90 over 360 would be what? 1/4 of the circle, right? So this is just a little bit more than 1/4 of the circle. Do you agree? So we're only finding 1/4, approximately 1/4 of the entire circle. So if I found the length, it would be that 2 pi r, correct? And r was 6. I could plug all that stuff in and get a number. I'm not going to do that right now. But we could also do the same thing with the area, couldn't we? We could, right? This is the best way I can color it in, just like that. Forget that it goes, there we go. Is that all right? All right, so what we want to do is find the area of this part of the circle. Now, this chunk of the circle right here, it has a special name. It's not just called the chunk of a circle or a part of the circle. We call it a sector, S-E-C-T-O-R, of a circle. Okay, a sector is that chunk, and it goes to the center of the circle. Everybody see that? So that's considered a sector of the circle. All right, so that's a new word for you. So we want to find the area of just that chunk. We don't want to find the area of the whole entire circle because the area of the whole entire circle would be what? Pi r squared. We just want to find a part of the circle, a fraction, a percentage of the whole circle. Alex? Okay. So how much of the circle are we trying to find? How much of the circle are we trying to find the area of? 92 out of 360. That's right. Okay, 92 degrees out of the total 360 degrees. We're not finding the whole circle. The whole circle would be 360 over 360, wouldn't it? We're only finding 92 out of the 360. And then you just plug the numbers in. So, in this case, R was what? 6? And now you just plug all that into your calculator. It's not that big of a deal, is it? So I got 92 over 360. Watch, 92 divided by 360. I just want to do this for, remember I said it's a little more than a quarter? So 92 over 360 is a little more than a quarter, isn't it? All right, so I'm going to take that, multiply it by 6 squared. You can do that in your head. What's 6 squared? 36. And then multiply that by pi. And then hit equals, and there you go, 28.9. So that's the area of that sector right there, 28.9. Now what if this 6 was in inches? This would be what? Inches squared, because it is area. Okay, even though it's only part of a circle, it's still area. So what we're trying to do here is we're trying to find out how many squares can we fit inside that little chunk of the circle. Well, 28.9 square inches I could fit inside that circle right there, approximately. You'll never know exactly how many. Why? Because pi, right, doesn't come out to an exact number. So you'll never know exactly how many, but you can get really, really, really close. Got it? I think that's about it. That was pretty easy, wasn't it? Yeah, I think that was pretty simple. Yeah, that's it for the whole lesson. It's not hard. It's easy to do. So let me give you some problems to do. feel left out, wouldn't you? If I didn't give you something to do tonight. So it's section 11.3. And look, I've given you a little bit of time to work in class on this. That's nice. So page 785, 786, 8 to 23. Now there's a few more than normal, but these are kind of easy though, so it shouldn't take you too long. So there it is. That's what you're doing tonight. By the way, does anybody look at the little itinerary, the lesson plans for this week?
No.
Quiz, not today. Tomorrow.
What?
Quiz 11.1 and 11.2. And that is tomorrow, Friday. Don't know. I don't even know if I have one made up. I got to go check to see. But you'll have it tomorrow. All right, 11.1, 11.2. And that will be tomorrow. Everybody good?